Hi everybody, very excited to say that I'm going to be at Oshkosh this year, which is in I think about a week's time. If anybody wants to talk to me about the air conditioner, please contact me. My details will be in the description below. You can email me or WhatsApp me, and be glad to meet up. I'm taking a few of the components across, so if you want to touch and feel, I'll be happy to show you. Just an update on the air conditioner. We started developing this aircon actually before the first TSi flew. So this aircraft, Mike India Kilo, did its first flight in beginning of 2020. We've done over 400 hours in this aircraft. We sold a total of about 6 air conditioners around Australia. This is the 3rd iteration mechanically, or the air conditioner, and we're on the 4th version of the electronics, which I'll go into a little bit later. But basically what we've done is it's essentially a motor car air conditioner. We've used a Sandon compressor. It's what they call a scroll compressor. Now, a scroll compressor over a piston compressor is where it's very good, is it doesn't give you that initial shock load. So when you turn the air conditioner on, a piston compressor will give you a very sudden thump, whereas a scroll compressor builds up the pressure before it actually starts pumping. And when I say builds up the pressure, it takes a split second to do that, but it's not a jolt. The compressor mounting bracket, to keep the weight down, we've used high tensile steel, so we've managed to keep the weight down by using thinner material. Again, this is the original compressor bracket. We haven't modified that. We've machined a billet aluminium pulley that drives the compressor and the alternator. Now, the alternator is also part of the kit. It's a 40 amp. It's also a Denso, the same as the factory Rotex alternator. That mounts on the other side. Now, everything is bolt on in the engine. Everything is standard. The only things that you'd have to do when fitting the kit is there's an extra 2 holes that go through the firewall for the air conditioner pipes. Then there's a modification on the cowling, only on the compressor side. There's no modification on the alternator side. Just incidentally, the alternator kit is available as a standalone. So if you've got an existing aircraft and you don't want to modify the cowling to take the Rotex bracket, you can fit it to the right hand side, and there's no modification of the cowl. So in the engine bay, it's only the pulley, the compressor, the alternator, and then the pipes. It's really important to not only have the cold air, but to be able to have the volume that the blow motor can push out. So this aircraft has got the 2 standard left and right air vents, and then we've added 2 additional air vents in the front. Now, the aircon does blow out of all 4 vents out of the evaporator. So stock standard, you'd have the 2 vents on the left and right. You'd have the one that comes out near the windscreen and then by your feet. In order to move the large volume of air, we've used a blow motor that can push out 310 cubic feet per minute, and it really does blow a lot of air. That's why the importance of having many outlets. You don't want to restrict it by the 2 standard vents. I've flown this aircraft and it's been parking in the sun for the whole day. We got inside it. It was so hot you couldn't even put your hand on the throttle. We started the engine, and within half a minute it was comfortable, it was cool, everything was still a bit hot, but the air conditioner performs extremely well. It's around about a 17 to 18,000 BTU unit, which is extremely powerful. What we've done, in my version, we had the evaporator sitting in the luggage compartment with an overhead ducting. But what we've done, we've simplified it and we've made it more like an automotive system where the evaporator unit is mounted in this area just behind the firewall. The unit utilizes the Sling factory's standard heater core, which is removed from the factory plastic housing and then is inserted into here and then capped off. So we're currently at the Global Aviation Build Center on the top of Tambourine Mountain. Errol's getting stuck in. So this aircraft's having an air conditioner, so it's got an auxiliary alternator and the compressor and the evaporator unit with heater fits against the firewall. All the air conditioner pipes are CNC bends by computer and run towards the back. And the condenser assembly sits behind the luggage bay. So the unit has two hoses for vibration. You have to have hoses coupling the compressor to the rest of the unit. The rest of the pipes are all CNC aluminium air conditioning pipes that go through the fuselage to the back to the condenser unit. So we spoke about the evaporator being up on the firewall. The condenser units, now in a conventional car, your condenser, you want a really large condenser because you have to remove a lot of heat from the cabin, and that's transferred through the gas through to the condenser. Now, normally in a motor car, your condenser would sit in front of the radiator and you have all that massive airflow to cool it, and it does need a lot of airflow. So what we've done, because you don't have the space up front, the condenser units, that's the baggage area and that's the back of the rear fuselage. So the condenser unit fits in here. It takes cool air from underneath, goes through the condenser and then out again through the air vents to cool the condenser. There is a condenser fan, so when you have low airflow, for example, just on startup or you're taxing, there is a fan that will come on when the gas pressure in the air conditioner is high. So it will monitor itself through the electronics, control that, and turn the fan on and off as needed. And obviously it'll do that in flight if necessary. But we've developed two vents like that. They're very low flow. We've tried probably 6 versions of vents. So that would just be the airflow. So you have airflow going in and then you have an opposite one where airflow goes out. We've done tests where we've had the air vents and then we blanked them off so it's flat and there's no noticeable drop in airspeed. So the drag is minuscule. Let's talk about some of the components that we used. As I mentioned, we've used a Sanden compressor. Sanden is one of the big boys in the international market for automotive compressors, Japanese company. The alternator is the same as the factory Rotax alternator, which is a Denso. Denso is a massive company owned by Toyota. The evaporator core we've used the most modern one that's available, which is called a plate type. It's a very lightweight evaporator core, and that's also made by Denso. The condenser core is a multi-flow, also the most modern type used, which is made by Sanden. So we've utilized all the most modern, most efficient components, all aluminium. So weight is a big aspect on this. If you go to older technology like tube and fin or serpentine, they perform not as efficiently, but there's a weight penalty. An example, the evaporator assembly, that is the blow motor, the housing, the electronics, and the core, a complete unit is 2.2 kilograms. So it's extremely light and extremely powerful. Controller, a lot of development has gone into that. We're on the 4th version of that. So its responsibility is to do the basic control of temperature of the air conditioner. So what it does is it monitors the evaporator temperature, make sure it never goes below 0, otherwise it'll actually freeze up the condensation, turns it into a block of ice. It also monitors your cabin temperature, but more importantly, it looks after safety of your engine and safety of the flight. So safety of the engine is if your pressures go too high, it monitors that the pressures have gone too high and will actually disable the compressor, enable the fans to reduce the gas pressure and only come on when it's safe to do so. It also monitors your battery power. So if you have your battery voltage starts going down, it'll isolate the aircon. It also monitors your RPM. So through an RS-232 port on the Garmin suite, it'll monitor your engine parameters. So we've made it very much a set and forget. So you turn the air conditioner on when you're taxing. When you go into takeoff mode and you apply full power, the compressor, not the fan, the compressor will actually turn off. So during the takeoff phase, it'll actually turn off the compressor. When you then go into the climb phase or cruise phase, the compressor will come back in. So it's very much a set and forget. You don't have to turn off the air conditioner. I have flown it with a family, with four people, max all up weights at 950 kilos. With the compressor on, we'd overridden that feature, so just to see what the performance was like, and it performs exceptionally well. So the air conditioner has a main isolation circuit breaker switch, which then powers up the controller. It has a temperature controller, which you can adjust at different temperatures. And if you want the heater on, you'd put it on 2 fans. So there's no air conditioner, no cold air, just the fan. Otherwise you can dial in the temperature of the cabin that you want. And then you have the various fan speeds. And the LED gives you, depending on the way the LED flashes, gives you different status of the controller. So it'll give you fault codes or just general operating codes. So with the aircon, the kit comes with everything. It comes with the electronic controller for the unit that's mounted up on the dashboard. It comes with the evaporator, the condenser, all the pipes. This is just an example of one of the pipes that is CNC bent. It comes with your engine bay hoses. Everything is pre-crimped. It comes with the fan, the condenser scoops that we spoke about. The machine billet aluminium pulley for the alternator and compressor. And then for your cowling modification, it'll come with, this one's out of carbon fiber, but we actually remanufacture them out of fiberglass just for a little bit more flex. But this is the component that you would, when you cut the hole for the aircon compressor on the cowling, this would go and you fiberglass this in place. So as far as the technical specs, the weight and balance, I'll put in up on the screen now. It's quite well balanced. There's weights up on the front on the gearbox, and then you've got the weights at the back for the condenser. The condenser's, I think it's about 6 or 7 kilograms. You've got about 8 kilograms on the nose, so it's quite well balanced as far as weight and balance. As far as power consumption, the only noticeable power loss is when you're in the cruise and the compressor comes on, you get about a 50 RPM drop. You don't notice an actual drop in airspeed, but you do notice on the display, you do notice about a 50 RPM drop. As far as currents draw, most of your currents is drawn from the evaporator blower, which is 19 amps. Compressor draws about 2 amps, and the condenser fan that comes on intermittently is about 8 amps. So that's why it's imperative to have an extra alternator. Originally, when we built the aircon, we thought we'd only be using it for taxiing, takeoff, landing when it's warm. But here in Australia on the east coast, and I'm sure other parts of the world, it does get quite warm. We did a trip in summer, 8,500. We were up in the air for 2 hours, and every time I turned off the air conditioner, it just got a bit stuffy. So we ended up using the air conditioner for the entire trip. So a lot of your summertime trips, you're going to use the air conditioner all the time. The controller does allow you to adjust the temperature. So if you're interested in buying a aircon for your TSi, if you're in Australia, get hold of Global Aviation Products. They can help you install the unit as well if needed be, or just supply you the kit. Internationally, it's also available. We have a production lot, the initial production run of 5 units, which are getting produced as we speak. And those are available either through Global Aviation, or if you want to message myself, details will be in the description below.